In this tutorial, like I'll demonstrate like how to use AutoML tools, like to fine tune the object detection model with a small data set in a COCO format. The key specifiers includes the installing dependencies, downloading data set, and creating multi-model predictions, and model fine tuning and evaluation, etc. So is a demo for that Hugo format dataset. So the first thing is the installation part, where libraries such as AutoGluon, Torch, MMV, and MMDE are installed in model training Inferno. So here is the model to install that MMDET and MMCV and etc. So here is the PyTorch audio and transformer installation and other things. So once it's done, then the downloading the data set has to be done. So here a small coco format data set that is a tiny motorbike data set is downloading, and currently it's in a JSON file which image annotations, bounded boxes and the labels, etc. So it orientates up with these kind of data. And once the data is done, then we are proceeding to the creating the multi-modular predictors. So for multi-modular predictors is initialized with a problem type of like an object detection or something. The medium the here we feed the medium quality data present based on the pre-trained YOLO X large scale object detection is selected here. Once it's done, then we are proceeding with the model fine tuning. So in the model fine tuning, the pre-trained model is fine tuned on the dataset with optimized learning rates and the configurations, ensuring it to the quick coverages and other things. So next thing is to evaluate the model. So for the here is all the training part and other things. So next is evaluate. So in the evaluate section, after training, the model is evaluated using coco matrix, like a mean average precision, like it's a map one. So once the evaluation is done, then we go for visualization and inference. So for the visualization and inference, here is the code for that, and the model generates boundary box predictions for the test data, and results can be visually using OpenCV and other tools. So here is the example for that, like how to visualize it with object detection visualizer and other things. So once the it's done, AutoML streamlines the predictions of fine-tuning the object detection models with a minimum setup, making it accessible and a quick experiment is the task for this. Like this is the testing section where whatever we performed, like it will test how many percentages we are getting and other things. So it is about the coco file predictions and the other thing, where last part I have explained till the previous one. So here this completes one model, that is text similarity and image classifier. So I'll be moving next to the image segmentations, where here is the that part, like where image segmentations will be performed. So here to start with, first we are going with a beginner data set in this tutorial. Like we are, explain AutoML for semantic segmentations, focusing upon fine tuning the semantic analysis models. Those are nothing but a SAM models, like using AutoGluon, SAM predictors, and a vast data sets. So Excel is generated using some specific domain task, like a medical or agriculture imaginary. Here we use a leaf disease segmentation data set for this one. So as in the first part, like here we import the panda import all the AutoGluon, Torch visions, and etc. So once this is done, then we need to load the data here. So we need the data of leaf disease segmentation data set to demonstrate how AutoGluon helps to fine tune the SAMs for the better results. So for here is the installation part of that, and once it's done, then we go for pandas installation, and the pandas loading in the test val and the train splitting part. Once it's done, then we go for the training head, like how it looks. Then we go for auto multi-model with this semantic segmentations. So it's low accuracy, but installation SAM performs zero shot evaluation with a low accuracy. But after fine tuning using AutoMM's easy API fit, then it significantly increases the performance. This approach allows SAMs to better identify a small disease specific areas in the plants. For example, here, like plotting the images and other things. So zero shot has a better accuracy compared to the other one, where from average to the above average it will take by the fit model here. So once the SAM is a better identifier of the small disease areas, so then the area in the plant showcasing its potential in specific applications, like it can go for full-fledged applications like fine tuning SAM and other things. So these will be performed here, and the disease part will be framed like this, and here is saving data and loading data for that. And the next part will be the different data set here, like we'll perform part ML for scan document classification. So here it has the same, like to fine tune the segment analysis model, and for the semantic segmentation task and other things. So in this particularly we'll use the leaf disease segmentation dataset to show how AutoML is better performed under the fit and other things. So here we use a multimodal data as a document, and installation part will be done here. So once the installation done, we load the training dataset below, and like this will be the splitting part and other things. The loading the data, we need to explain the document parts to load the trend. So here is the lambda function explaining the every part of that. And let's play one of the document, like as you can see, like this budget document consists of account number, account name, and everything. So here this has to be kept in a safe place and using some privacy of follow-ups on this, like building scanned documents and other things. Like here it will show the exact things, that is model document transform checkpoints and other things where we can predict, and it will be the faster way. So evaluating the models, and here is a predicting a new kind of model. It's satisfying the predictions and accuracy. So here is everything. So here is the extract embedding from the full document learning by a model also will be very useful. We provide some extra embedding functions to allow the predictors to return it to the end dimension document features and end depth of the models. So for that reason, like we are using the embeddings. And but the last part, we have the data set for resume and historical document using the classifier. It's nothing but a PDF kind of a document with AutoML tool. Like in this one, like PDF documentation using AutoML with a minimal efforts. Like AutoML simplifies the process of building the machine learning models of the PDF documents, handle task via like a document format detections or a text recognition or the conversation with a manual intervention. So in this example, the dataset configuration is resumes the historical document by using the classification and other things. So using this multi-modular predictor API, PDF document classifier is a built-in trained within a seconds. Like after training the model, so it's evaluate for accuracy based on the test data, and the predictions are made on a new PDF. So the tutorials also demonstrate how to exactly demonstrate this further analysis and other things. So here is the installation part for that, and once the installation is done, like importing the torch vision and other things, then auto glue and upgrades and will be performed here. Now let's see how to PDF documents visualize. Here is the S3 upload of the PDF document iframe. So in this tutorial, like here is I don't know, the page has been blocked by Chrome. Maybe it's some kind of not oriented data or something. So here once is done it, we can see the document of American history PDF to make sure a multi-module prediction can locate the document correctly, and we need to override the documents and creating a PDF classifier is this part. And there's the evaluation of the on the test data set. So once it's done, then we need to evaluate the data and making in new predictions for the new kind of data and other things. So this is the all about the things. So yeah, this explains the image segmentation part, and covering with the previous text similarity matching and image classifier. This combines them like in depth. Yeah, thank you.